All right, students, this is your flipped lesson on relations and functions. So let's begin with relations. So a relation is basically talking about the relationship between any set of ordered pairs. In other words, we could talk about the relationship of x and y. We could, in an ordered pair, in a table, it could be, input, output, the independent, dependent. They have a relationship. Graphs, we see relationships. The X and Y create physical locations that you can find. The new one here is probably mappings. So this is probably a new idea for you. And once we go over a few of these, I think you'll quickly understand it. Now, within a relation, we have what's called the domain, which is basically your X's or your inputs, and the range, which is the outputs or the Y coordinates. So when we talk about the domain, where the domain is commonly thought of as where you are at. Your personal domain is around Luna Middle School. We're talking about all the possible inputs, and the range. I looked this up because it was kind of weird. The range used to be called the codomain or the image. Well, they settled on this word range because it was less confusing somehow. But I digress. Range is all the possible outputs from the input domain. So if you look over here, it makes more sense. Ordered pairs, here are your X's, the domains, and the range are the Y's that go along with those, or the outputs. So let's talk about the mapping. So basically, if you put in a -2, you get a 3. If you put in a 0, you get a -1. If you put in a 1, you get a 2. If you put in a 3, you get a 1. This is a function because if you notice, all of the inputs have only one output. Okay, and here again we see it in table form, and here we see these points have every X has a unique Y. In other words, when we put in X is 1, we only have one Y. We don't have multiple Y's. Okay, so that's what we're building up to right here in functions. A function is a relationship in which every member of the domain, every X or input value, is paired or mapped to exactly only one range, one output value. So an example of the function m equals 20n, where m represents the amount of money earned. So I earned $20 for every number of lawns. If I mow 2 lawns in, I'm not going to sometimes get $40. I'm only going to get $40 because that's the 20 makes it so that my m is $40. So it all goes back to your independent, dependent variables. If you have an independent variable, you should only get one outcome from that. That's what makes it functional or a function. So in other words, each x value can be matched with only one y value, and a relation cannot have an x value repeated. A relationship cannot have an x value repeated without having the same y value. So let's look at this domain. If I put in 1, I get 3. If I put in 2, I get 5. And if I put in 3, I get 5 also. So something happened here where no matter, this is a function because I can only get 5 out. That's the maximum. If I put in 1, I get 3, but if I put in 2 or 3, I get 5. So this is a function. A domain has, here we have, if we put in 1, we get either 3 or 5. Well, that doesn't make any sense. If I put in 1, I should get only one of these two things. So this is not a function. This is an example of a mapping where you can not a function. In a function, we can share an output, but in a function, we cannot share an input. Okay, so we're going to look at the next page and represent the relation as a table, a graph, and a mapping. So here we have these coordinate pairs. So the first one, 3, -4. I just put in 3, -4. 2 and 0. -4, and -1, and 0, and -3. I've basically created my domain and my range. If I put in 3, I get -4. If I put in 2, I get 0. If I put in -4, I get -1. Put in 0, I get -3. Now, as a mapping, maybe I want to put these in order. So I'll start with 0, then I'll go to 2, then I'll go to 3, and I missed that -4. That probably should have been way up there at the top first. No big deal. So in my range, I can put these in any order. So I'll put them in this order: -4, 0, -1, and -3. And now I'll map it. So my 3 gave me -4. So I would draw that arrow. My 2 gave me 0. My -4 gave me -1. My 0 gave me -3. I have mapped my domain and my range. And of course, you all know how to do this. 3 gives me -4, so I go from 3 down to 1, 2, 3, 4, 2, and 0, -1, 2, 3, 4, and -1, and 0, and -3. Now, one thing you need to notice here is that we're not looking for any sort of linear relationship here. These dots are all over the place. Okay, all we're doing is we've represented the relationship in a table, a graph, and as a map. Okay, now we are going to look at something. So we're going to relate how these different graphs, are they a function or not? Now remember, we said when we have a function, we know x value, no x value can share a y value. An x value, I'm sorry, no y value can share, no x value can, these x's can share this y. That's possible. Because we might have hit a limit. Maybe the maximum you can get out of this is 5. No matter if I score a 2 or a 3, the most I'm going to get is 5 points. But here, if I score a 1, I should either get 3 or 5. So whenever I have an x, I cannot have more than one y. Whenever I have an x, I cannot have more than one y. So let's relate that to this. Notice this curved line. Is it truly curved? In other words, if I have, as long as I have an x, because it's not quite vertical, I should not be able to draw a vertical line and run across two places that mark a point of x. So this is a function. Now this is a good example of not a function, because if I have my x is 4, I have two y's, I have two outputs right there. So this is not a function. Okay, what do you think about this? Is there truly any sort of overlap or anything in my x? It looks really steep, but I don't think if you look closely, it's always slanting, and no x value, no exact x value has more than one y value, because as the x moves left to right, the y value moves up and down. Okay, so this is a function. All right, so let's look at the circle. The circle. If my x value is 1, I can get a y here, and I can get a y there. And if I can draw this straight line and hit more than one point on the line, then it is not a function. So what do you think about this? This looks close like it's not a function, but it curves. This, obviously, if we can draw a straight line up and down, then it is a function. All right, so here we move into a bunch of dots, and I'm going to zoom in so it's a little bit easier, because your copy, it might not be very legible. So are there any stacked dots? That's my question. Is this dot stacked on this dot? That means for this x value of -2, I get 8 and -1. So this x value is, I don't know what it's really going to give me. If I put in -2, am I going to get -1 or am I going to get 8? So that's not a good thing. That's not a function. Okay, looking at this one, what do you think? Are any of them stacked up, or any of the y values sharing an x value? So I do not see a stacked dot. So yes, that's a function. Okay, so any x's here, I have a dot here. X0, I get 2. X2, I get -8. X4, I get -8. Now, is that okay? Is that a function? If you go back here, when I put in 2 and 3, I got 5. So it might be in this particular case, there's a range here where there's in this area of the domain, I get this particular output. Okay, so this looks like, look here, if I put in -2, if I put in -2 again, like this one here, I might get 0 or I might get 7. So that's not very functional, is it? That doesn't help me. So this is not a function. Okay, so we've done a little bit of that, and I'm going to go through this back half of the assignment. Identifying functions from tables. So this x gives me 8, this 4 gives me 7, this 6 gives me 5, and this 8 gives me 2. That's a function. Okay, no x value gives me the same, no x values share a y value. These are all unique y values. Okay, let's look at these y values. So I have 1, 2, 3, 2. My x values are 3, 5, 7, 9. Okay, so if I put in an x, am I going to get a different y? What's being shared here? And let's think about, does that work or not? So I've got unique x values, but I have repeated y values. So basically what it's saying is if you put in 5, you might get 2. If you put in 5, you'll get 2. If you put in 9, you get 2. So based on our notes on the first page, is this a function? So in the notes on the first page, I could put in 2 or 3 and get 5. So yes or no, is it a function? The answer is yes. Okay. All right, looking at the next one. Yes, function. We have a -2, a 2, a -4, and a 4. So we have varying x values. No x value is repeated. Okay, doesn't show up again. So it doesn't really matter what's over here. This is a function. Yes. Okay, no repeated x values. Okay, unique y values. If everything's unique, we're cool. 2, 4, 6, 8. Okay, so 4 and 4 and 5 and 5. So if I put in a 2, I get 4. If I put in a x, I get 4. If I put in a 6, I get 5. And I put in a 5, 8, I get 5. Is this a function? Okay. Yes, because as we saw in the first notes, okay, in these ordered pairs, you can put in different x's and share a y value. You just can't put in an x. You just can't have the same x giving you different outputs. You can't. So every input gives you an output that is, and so it's unique inputs. Okay. All right. So unique inputs. We have 1, 1, 2, 2. So if I put in a 1 here, I get an 8. If I put in here 1, I get a 7. They need to make up their mind. So this is no. So reflect. Write a statement here about how you can tell if a table is a function. Okay. So in this one, these two, you can put in pretty much anything you want. Just complete the table that it is a function. Here, maybe you can complete this table where it's not a function with x values that would not make it a function. Here with x values that would make it a function. So I wanted to real quick answer what you might have put in here to make this that it is a function. So if we put in 1, 2, 3, 4, we have, from what we can tell, this is a function because we have completely different x's and we have completely different y's. So whenever you have different x's, different y's, you're in good shape. It's a function. if we have an x10 and x11, to make this not a function, so we would have to say, to really make this true, we could do like 10 again, because sometimes I get, if I put in 10 I get 2, if I put in 10 I get 6. I could put in and throw in another 11, because sometimes then I get 11. If I put in 11 I get a 4. Sometimes if I give 11 I get 8. So that's what makes that, would make that not a function. So those are just examples of, well, I mean, you could have done 10 and 10 or 11 11 here, but anytime you have an input with the different outputs, it's not a function. So I wanted to add that. Okay, we're on the back page now. We're going to look at identifying functions from coordinates. So the difficulty with these really is just kind of organizing it. So remember, if we have any given x should only give us one y output. So if we have unique x's 4, 5, 6, 7, we can have repeated y's, but in this case we have no repeated anything. 4, 5, 6, 7, 2, 6, 10, 9. Okay, so this is a good function. Yes, function. Okay, 4, 5, 6, 7. Okay, so in each of these, every single one of these x's repeats the same value. Yes, this is a function, because sometimes no matter how hard, no matter how much I put into something, I'm going to get the same thing out. Okay, so we're going to have fun or no fun right here. Let's look. Now here I put in a 3, I got out a 4. Here I put in a 3, I got out a 6, a 3, I got an 8, a 3. Okay, it needs to make up its mind. So this is an example of not fun. Okay, 4, 4. 5, 4, 6, 4, 7, 4. Put in a 4, I get out of 4. Put in a 5, I get out of 4. Put in a 6, I get out of 4. Put in a 7, I get out of 4. What do you think? Function or not function? Fun or no fun? Okay, if you said fun, you're right, because in this case I just have different inputs with the same output, and that's okay. But different outputs with the same input is confusing. Okay. 1, 0, 3, -2, 5, 2, 7, 4. Different inputs and different outputs. No same input, no same output, so that's definitely a function. Okay, what do you think about this one? Put in 6, I get out 1. Put in 7, get out 3. Put in 8, get out 3. Put in 9, get out 1. Okay, so if I put in 6 and I get out 1, I put in 9, get out 1. Does that mean it's not a function? It is still a function. It is still fun. Okay. Now, so write a brief statement here. Pause the video on how you can tell if a list of points is a function. Be prepared on these reflective parts to share out, tomorrow, or we may create in the Google Classroom a way that you guys can share that with each other. Okay. Complete the list so that it is not a function. All right, so I want not a function. We did this before, right? So I have an input 1, 5, 2, 7, 3, 0. So to make this work, I need to have the same x, different what? Y. So what if I came back and said, well, put in 1 this time and I only got 2 back? That would be not a function. So that it is a function, I could repeat. I could say 2 and 7 again, or 4 and 5, or 6 and 6, or just put in some random other input output, anything. You could have an infinite amount of possibilities in this to make it that it is a function. Okay, so we're going to go back to our mapping, because this is the new thing. This is one of the newer things besides the idea of what is a function, what's not a function. Okay, so I put in a -8, I get a 32. I put in a -4, I get a 24. I put in a 4, I get a 24, and I put in an 8, I get a 32. Okay, Is this a relation? Well, sure, yes, because we have domain and we have range. Okay, we have range that is specific or limited to two things, but our domain is four things. Our range, this is still a relation. Is it a function? Okay, is it a function? Yes, because we don't have repeated, we don't repeat the domain. Domains are all different. Okay, domain 156, range 249, is this a relation? Sure. We have domain and we have range. Okay, is it a function? Is it a function? Okay, if I put in a 1, I get a 4. If I put in a 5, I get a 2. If I put in a 6, I get a 9. Yes. Okay, we don't have any, no repeated. No repeated. Okay, if I put in a 1, I get a 4. If I put in a 5, I get a 2. If I put in a 6, I get a 4 or a 9. So is it a relation? Sure, it's a relation, because they have x's and y's, but is it a function? Okay, so if I put in a 6, how do I know if I'm going to get a 4 or 9? I don't have confidence in that. It's not a function. 6 gets me different. X as 6 gets me different y's. Gets me different y's. Okay, and I'm going to close with just two last things. Remember, relations are any combination of ordered pairs. There's no stipulations on what a relation is. The x is the domain and the y is the range, or the input is the domain, the output is the range. The independent variable is the domain, the output's the range. Functions, however, have these weird limitations, and the main rule is that if you put in an x, it should only give you one y. Any given x, 1 should always give you one output. Any single input should only give you one output. You should not be able to put in an input like 1 and get either 3 or 5 as the output. And we looked at different representations of what that looks like in tables and graphs and ordered pairs. So that's the main thing to think about. Hope this was comprehensible and you feel ready for your benchmark tomorrow. Good luck.